24. Determine the cell reaction and the standard cell potential at 25 degrees Celsius for a cell made from a cathode half cell consisting of silver electrode in a 1 molar silver nitrate solution and an anode half cell consisting of a zinc electrode and a 1 molar zinc nitrate. Is the reaction spontaneous at standard conditions? Okie dokie. So, seems like we have to do a couple of things here. They want us to write out some type of cell reaction, aka a balanced equation. They want us to find the standard cell potential and whether it's spontaneous or not. So, the first thing here is, what are we going to do? Let's see. Well, they give us a little hint. They do say that we're dealing with cathodes and anodes. Thank goodness. Now, cathodes and anodes have to deal with cell potential. If we're trying to find a standard cell potential, that is a E cell value. The notch at the top, that just means that we're at standard state conditions. And they keep saying standard, right? Standard cell potential, standard conditions. So with standard values, I am going to the back of the textbook to find out those cell potential values for the half reactions. Now, when we're doing this, the formula to find that standard cell potential, the E cell, is this. So let's just put that up here for now. We'll start off with how to find the standard cell potential. The formula is cathode minus anode, the cell potential of the cathode minus the cell potential of the anode. Keep in mind that reduction is happening at the cathode. You're gaining electrons, you're becoming more negative, and oxidation is happening at the anode. You're losing electrons, so you're becoming more positive. However, we don't really need to know which one is the cathode or which one is the anode because they already told us that. So I'm just going to leave it as cathode minus anode. Now, in this case, they did say that the cathode half cell was consisting of silver electrode. Now, they're talking about silver electrode. Electrode is just a fancy way for saying that I have a silver solid. Silver on the periodic table is Ag. And the cathode half cell is the silver one. So the cathode has to have Ag in it. That's the silver. Now I'm just going to shoot right over here. They told us specifically that the anode half cell consists of the zinc electrode. An electrode, remember, is just a fancy way for saying a solid. Specifically, zinc on the periodic table is Zn, and that's at the anode, so I know that the Zn is at the anode. So I can go in the back of the textbook to find out what the half reactions are for the silver and the zinc, right? I mean, I have to do that. They didn't give me any cell potential value, so I have to do that. Now, I picked the right ones that are according to this equation, this question, and just know that silver, there's only one half reaction in the back of the book for silver, and there's only one half reaction for the zinc because Ag only has one charge, is +1, and zinc only has the one charge as well, it's +2. Now, if you're doing cathode minus anode, if you're specifically doing the minus, you do not have to change any of the cell potential values. The negative flips the anode, basically. But the negative is going to do it for you. Just less work. So we're just going to go straight for it. The cathode Ag value is this 0.7996. And then I'm just going to subtract the zinc, which is a negative 0.7618. So let's first find out that E cell, and then we'll have 1/3 of the question done. 0.7996 minus a negative 0.7618. Whoop. And there we go. We get 1.5614, and that is in the units of volts. All right, so 1/3 done. Now from there, from every time that you get an E cell, right, the standard cell potential for a whole entire reaction, you could always go straight to finding out if it's spontaneous or not, because that just goes by what the sign of the E cell is. If the E cell value that you got is a positive value, the reaction's spontaneous. But if the E cell that you got is a negative value, it's non-spontaneous. But here, we got a positive value, so we know that this reaction is a spontaneous reaction. That means that it does not need any more additional energy to make this reaction run. So 2/3 done. Now, what happened to that? Let's just take it. There we go. Now, we're just going to find the cell reaction. Well, here are the two half reactions, so we could just take it from there. We're not going to care about nitrate because nitrate is always going to be nitrate. There's no change in the charge of a nitrate. It's always going to be a -1. Remember, cell potentials have to do with oxidation reduction. Only the ones that change their charges or their oxidation states. Now just know that when you have a balanced half reaction with electrons on the left side of the yield, that's always going to be the cathode. By having electrons on the left side, that means that you gained electrons. And the Ag was the cathode, so this equation checks out. So I'm going to have Ag plus, and just know that the plus is in aqueous, just in case you need a charge. So this would be the electron, yields, just the Ag by itself is the electrode, that's the solid. Now, the anode, they specifically said that the anode was a zinc. However, the electron is on the left side as well. That's a cathode. We want it to be the anode. What would we have to do in order to make this balanced equation an anode? Yeah, you're going to just have to flip it, in which the zinc solid is now on the left side, and these two are on the right side. So that's what I'm going to do. I'm going to say zinc yields the Zn2 plus, that's aqueous, plus the 2 electrons. Okay. Now, I want to make this into one balanced equation, so I could add it together and call it a day. But I can only do that if the electrons are the same. I have 2 electrons for the zinc, but I only have 1 electron for the silver reaction. How am I going to make this have the same amount of electrons? Well, you do it by multiplying. I could take the first reaction and times it by 2, because 2 times 1 will get me 2. But you got to be fair. I have to multiply all of the species that are in the first equation. I'm just going to pull this down. And now I'm going to say that I have 2 Ag plus aqueous plus the 2 electrons. And that's going to yield the 2 Ag solid. Now, since I have those electrons being the same, I can add these equations up and simplify the electrons. The electrons will cancel. Technically, anything else will cancel as well, but I have nothing else that's the same. So all the reactants stay on the reactant side, all of the products stay on the product side. So now I got 2 Ag plus aqueous plus the zinc solid yields the 2 Ag solid plus the Zn2 plus aqueous. And now we have that cell reaction. And let's just box it off. Whoop, whoop. There we go. What'd you think? I hope this helped. Let me know in the comments. Subscribe to the channel. I hope you all are having a great day out there. Keep studying hard. Thank you so much for all your kind comments and your support throughout this whole YouTube journey. And I'm so glad that, a lot of you are using this channel to help you out in your chemistry class. And we also have physics and math videos on the channel as well, so you could check out those subjects if you guys are in those subjects, or maybe you have friends or classmates that are in that subject, with more subjects to come, so stay tuned. Thank you so much, my brother and I. We really do appreciate you all, and let's just keep learning. All right, bye-bye.